Hello everyone. So in the previous video, we discussed the theory behind this question, container with most water. In this video, we'll be solving the question using the approach that we discussed previously, namely the two pointers approach. So just to give you a very brief recap, we said that we can take two pointers, right? One will be at the leftmost wall, one will be at the rightmost wall. We'll keep calculating the area, which will be calculated in such a manner that whatever is the height of the shorter wall will be considered the length of the rectangle, and the space between them would be considered the breadth. That's how we calculate the area. And at every step, we'll calculate the area. We'll check if it is the greatest area we've encountered so far, if it is the container with most water. And if it is, we'll update our answer. If not, we will move on to the next pointer. All right. So that's basically what we have to implement. So how do we go about initializing our solution? Let's start off with the area, which will actually be our answer. So we have that over here. Then our two pointers. The first pointer, as I said, would be at the leftmost wall. The other pointer would be at the rightmost wall, which will be found at the last index of the array. Alright. Now we have to keep on iterating till the left pointer and the right pointer reach the same position. We discussed that previously. Alright. So if it is not clear to you, I suggest you go on and watch that video before we move on to the solution. So while the 2 points are distinct, while they are not at the same position, what will we do? We will calculate the area encapsulated by the walls at those 2 points. So for that, we need two components, right? First, the height that we have to consider as the length, then the space between them. So let's say the length would be the minimum of whatever two walls we have. So the two walls we have are at the lth and the rth index, right? That will be our length. The breadth would be the space between them, which is simply the difference between the 2 points, right? For example, if we are comparing these two walls, so r would be at 1, l would be at 0. So r minus l would be 1, which is the space between them. That is the logic behind this. The area is, of course, length into breadth. All right. Now, this will give us the area, of course, and if this area is greater than the answer that we had so far, so to speak, this is the greatest area that we've encountered so far, we will simply update our answer. Now the question is, this is how we calculate the area, that's fair enough, but how do we move the points? So we discussed previously that we either move the left pointer or the right pointer, depending on whichever wall is shorter. So if one of our pointers is over here at 0th index, the other is at the last index, I will move the pointer from wherever the wall is found to be shorter, in which case we will move the pointer from 0th index forward to the first index. Alright. So that is what we have to do, because we have to look for a wall that is bigger so that it can form an area that is also bigger. Right? The container has to store the most amount of water. So that is what we'll have to do. So we will check if the height at the left pointer is less than or equal to the height of the right pointer. The equal to is actually of no significance. We can simply remove it as well. You can keep it, you cannot keep it. It's up to you. The answer would remain the same. Alright. If the height of the left pointer is less than the height of the right pointer, that means left wall is shorter. So we increment the left pointer. Right? Otherwise, we will decrement the right pointer. Now this seems complete enough as an answer. So let's try to submit this. Oh, we haven't returned it. Wait, this will not work. We have to return it first, of course. Yeah, this seems complete enough. So let's see if this works. All right. Now this will work. And let me submit this to prove it to you that it will work. But there are more things to discuss over here. All right, see, it's been accepted and all of it's good. But the thing is that we are doing a few redundant operations. For example, if we are at this wall right here and the right wall is over here at the very end, we can keep moving this wall and reach a place that is, well, in this case we would be moving the right wall, right pointer to the one that is left to it. But here we notice that the wall is actually shorter and the distance is lesser than before. So naturally the area will be lesser. The container will not be bigger than what we had previously, for sure. So can we actually skip such conditions? I say that we can. For that, we will simply store the current height, current left height in this case. Right, current left height would be height at the nth index. And I say that while this particular height, and of course we move the pointer then, and I say that whatever is the new height found at the left pointer, while this height is less than or equal to, this equal to is important, is less than or equal to the height that we just moved away from, in that case we should keep moving forward, because in this case our answer, our area will certainly not be bigger. All right, so this is what we do over here, and we have to repeat the same for the right pointer. So we just copy some of it. This is our right height, and of course we have already decremented our right pointer, so we don't need to do that again. And in this condition we will simply accommodate it for the right pointer, and we'll say that if the height of the right pointer is less than the height of the right pointer we had previously, so the area will not be bigger, so we can keep moving till we reach a wall that is bigger, simply speaking. And this should also give us the correct answer. And I say that in bigger systems, in large scale systems, these sort of edge cases help you optimize the process, even if the result may not reflect on Leetcode. And as you see, the answer has been accepted. So you have this approach, and of course the brute force approach that we discussed in the explanation video. So you have two approaches to solve this problem, and I hope that helps. And of course, follow for more.